Most people think quantum computing is still locked inside research labs, universities, and theoretical papers. Something that belongs to the future, not to today's market. But what's starting to happen is that quantum concepts are quietly blending with artificial intelligence and real computing hardware in ways that are already being used right now. And surprisingly, some of the companies building this bridge between AI and quantum-style computing are trading under $3. The first company doesn't build quantum chips or massive machines. Instead, it applies quantum-inspired algorithms and artificial intelligence to one of the most complex problems in the world: discovering new drugs for cancer and rare diseases. Drug discovery is normally a slow, expensive process that can take years of lab testing and billions of dollars. The challenge is not just testing molecules, but predicting which ones might actually work before ever entering a lab. This company uses advanced AI models combined with quantum-style optimization techniques to simulate how molecules interact with biological systems. Instead of randomly testing compounds, the system narrows down candidates using computational modeling that mimics the kind of complex probability calculations associated with quantum computing principles. The result is a platform that can analyze huge biological datasets, predict outcomes, and drastically shorten the early discovery phase. What makes this very specific is where it is used. Pharmaceutical research environments, biotech partnerships, and oncology-focused drug programs are using this platform to identify promising drug candidates faster than traditional methods. The AI doesn't replace the lab, but it tells researchers where to look before expensive testing begins. This matters because the biggest bottleneck in drug development is early-stage prediction. If you can use AI and quantum-inspired math to eliminate thousands of bad candidates early, you save time, money, and resources. That's exactly where this technology sits. This fits into a broader shift where AI is not just analyzing images or text, but solving highly complex scientific problems that involve probabilities, molecular behavior, and biological systems. The company's platform is designed specifically for oncology and rare disease drug pipelines, areas where precision and speed are critical. The business model revolves around partnerships, licensing its AI platform to pharmaceutical and biotech companies, and working on collaborative drug programs where its technology is used as the computational engine behind discovery efforts. The traction comes from active drug programs in development, where this platform is already influencing real research pipelines. The company behind this approach is Lantern Pharma, trading under the ticker LTRN, currently priced around $2.64 per share. Despite operating at the intersection of AI, quantum-inspired computing, and drug discovery, it remains relatively unnoticed in the broader quantum or AI stock conversation. It's not building flashy hardware, but it's applying advanced computation to a problem that directly impacts human health. What keeps this stock at these levels is the early stage of its drug programs and the niche nature of its technology. Drug development timelines are long, and awareness of AI-driven discovery platforms is still growing. But the second company takes a completely different angle on quantum. Instead of applying quantum concepts to software and biology, this one focuses on building the hardware and compute infrastructure that supports advanced computing workloads, including quantum and AI research environments. This company develops specialized compute hardware and systems designed to handle extremely demanding workloads that traditional servers struggle with. These systems are built to support complex simulations, AI training, and future quantum-compatible computing tasks that require massive parallel processing power. What makes this unusual is that it sits between traditional data center hardware and emerging quantum computing need. The hardware is designed for research labs, universities, and enterprises working on advanced computational problems that push beyond standard server capabilities. These systems are used in environments where high-performance computing is essential, including AI model training, scientific simulations, and experimental computing research that overlaps with quantum development efforts. Instead of waiting for full quantum machines to become mainstream, this company builds the infrastructure that can support those workloads today. The business model combines hardware sales with system integration and specialized compute solutions for institutions and organizations working on advanced computing problems. The validation comes from deployments in research and enterprise environments where high-performance computing is already in demand. The company behind this approach is Axe Compute, trading under the ticker AGPU, currently priced around $2.30 per share. Like the first company, it operates in a niche that doesn't get mainstream investor attention. It's not a consumer tech brand. It's a compute infrastructure provider for highly specialized use cases that intersect with AI and future quantum computing demand. What keeps this stock at these levels is scale and visibility. It operates in a specialized hardware segment that grows through contracts and deployments rather than hype cycles. When you compare both companies, you see two very different ways quantum ideas are entering real markets. One uses quantum-inspired computation and AI to solve biological problems in drug discovery. The other builds the hardware foundation that supports advanced computing workloads tied to AI and emerging quantum research. Both are already being used in real environments, one inside pharmaceutical research pipelines, the other inside research and high-performance computing setup. Neither is theoretical, and neither is waiting for the future to arrive. The future outlook for both depends on adoption and expansion. As AI continues to move into scientific research, and as computing demands grow more complex, platforms that combine advanced algorithms with specialized hardware will become more important. At the same time, there are real risks. These are small companies operating in technical, niche markets. Growth depends on partnerships, contracts, and the ability to scale in specialized industries. Larger players could enter these spaces. And both fields, drug discovery and advanced computing hardware, move at a deliberate pace. But what makes these two stocks interesting is not hype around quantum. It's how quantum concepts and AI are already being applied in real-world systems today, while both companies trade under $3. And what makes this even more interesting for small-cap investors is how early this category still is in the public market conversation. Most discussions around AI focus on chatbots, data centers, and big tech names, while quantum talk often stays trapped in academic headlines. But these two companies sit in a quiet intersection where advanced computation is already solving real problems in medicine and powering the kind of high-performance environments that future quantum systems will rely on. They represent a part of the AI and quantum story that isn't flashy, but deeply practical, where progress happens through deployments, research partnerships, and specialized infrastructure. Watching how these niches evolve over the next few years may reveal just how important these early players were in shaping the bridge between today's AI capabilities and tomorrow's quantum computing landscape.